AD633 Monolithic Analog Multiplier. Introduction. AD633 is a functionally complete 4-quadrant analog multiplier available in 8-pin PDIP and SOC packages. This includes high impedance differential inputs X and Y and a high impedance summing input Z with a 10-volt full-scale output. AD633 is used for various applications like multiplication, division, squaring, modulation and demodulation, voltage controlled oscillator, etc. Some product highlights of AD633. This is a 4-quadrant multiplier with no external components or no expensive user calibration. High input impedance and low output impedance. Power supply ranges from plus or minus 8 volt to plus or minus 18 volt. Pin diagram of AD633 JN/AN variants. There are 8 pins. Pin number 1 X1, pin number 2 X2, pin number 3 Y1, pin number 4 Y2, pin number 5 is minus Vs, pin number 6 is external input, pin number 7 is output W, pin number 8 is plus Vs. This is the internal diagram of AD633 JN/AN. Block diagram of AD633 AN/JN. So the internal diagram consists of 3 operational amplifiers. 1 analog multiplier with 3 inputs and 1 2-input summing amplifier. Out of the 3 operational amplifiers, 2 operational amplifiers are configured as differential amplifiers and the third operational amplifier is wired as a voltage follower or buffer amplifier. AD633 is an analog multiplier manufactured by Analog Devices. There are different versions, PDIP and SOC for this chip. Internal diagram and functionality of both these variants are same. Our discussion is based on AD633 JN/AN, which are the 8-pin PDP package. AD633 consists of 3 high input impedance operational amplifiers. First 2 operational amplifiers connected as differential amplifiers and third operational amplifier connected as a voltage follower. Output of first 2 op-amps is applied to a voltage multiplier with a scaling factor of 0.1 volt. Multiplier output is applied to a 2-input summing amplifier whose second input is an external signal Z. Output of summing amplifier is connected to the output W through the third op-amp connected as a voltage follower. Expression for output voltage. Output of first differential amplifier is X1 minus X2. Output of second differential amplifier is Y1 minus Y2. Output of the multiplier is Vp is equal to 0.1 into x1 minus x2 into y1 minus y2. Output of the summing amplifier is VQ is equal to 0.1 into x1 minus x2 into y1 minus y2 plus z, where z is the external input. Output V0 is equal to 0.1 into x1 minus x2 into y1 minus y2 plus z. Applications of AD633. AD633 can be used as a squaring circuit, analog multiplier, frequency doubler, variable scale factor, linear amplitude modulator, voltage controlled high pass and low pass filters. AD633 as an analog multiplier. So plus 15 volt, minus 15 volt applied to plus Vs and minus Vs respectively. Input signal V1 applied to first two inputs 1 and 2. Input signal V2 applied to the second inputs between 3 and 4. External input Z is connected to ground. So V0 is equal to 0.1 into V1 into V2. If V1 is equal to V2, AD633 becomes a squaring circuit. V0 is equal to 0.1 into V1 into V1. So V0 is equal to 0.1 V1 square. If input V1 is a sine wave, then this becomes a frequency doubler. If input signal V1 is a sine wave, then output voltage V0 is equal to 0.1 V1. Output voltage V0 is equal to 0.1 V1 square. Let V1 is equal to Vm sin omega t. V0 is equal to 0.1 into Vm sin omega t whole square. V0 is equal to 0.1 Vm square sin square omega t. Sin square omega t is equal to 1 minus cos 2 omega t by 2. So V0 is equal to Vm square into 1 minus cos 2 omega t the whole divided by 20. Omega is doubled. That means frequency of the signal is also doubled.